Hey guys, I'm Manan from Movie Data Scientist, and in this new video we are going to talk about feature scaling. What are the different types of feature scaling? What is data normalization? What is min-max normalization? Then we'll talk about z-score normalization, or it is also called as data standardization, and what is robust scaling. So let's get started. First, let's talk about feature scaling. So it is an important step in pre-processing of the data for machine learning algorithms. It is very helpful to transform the range of independent variables or the features of the data to a common scale. So this is known as data normalization or standardization. Now let's talk about types of feature scaling. The most common type of feature scaling is min-max scaling, which is also known as normalization. Min-max scaling transforms the data so that all the values are between 0 and 1. This is done by subtracting the minimum value from each data point and then dividing it by the range. Second comes standardization that transform the data so that the mean of the data is 0 and the standard deviation is 1. This is done by subtracting the mean from each data point and then dividing the whole by the standard deviation. In the last, we have robust scaling. It is actually pretty much similar to min-max scaling, but it's really useful when there are outliers. So instead of subtracting the minimum value from each data point, the median value is subtracted. So this helps to reduce the effect of outliers of the data. Now let's move forward and import all the necessary libraries which we are going to use in this video. So here, as you can see, that we are going to import NumPy, Pandas, train set split, logistic regression, classification report, ordinal encoder. Then we are going to import StandardScaler, MinMaxScaler, and robustscaler. So once we are done with it, then we can move forward and import the dataset. For this problem, we are going to work on Internet Firewall dataset. So we have 12 features in total, and the action feature is used as a class. So there are total 4 classes. Now let's download the data. For that, we are using a read CSV function. Here, as you can see, that I've provided the URL. Now let's have a look at the top 5 rows while running this code. It might take a couple of seconds. So here, as you can see, this is our data set. Now let's have a look at the data set. So only one column, that is the action column, is a categorical column. So as you already know, you cannot work with the categorical column. It has to be converted into a numerical column if you want to use an estimator from Scikit-Learn. For that, we have multiple options. The first one is one-hot encoding. It encodes the value into binary values. And second one is an ordinal encoding. So this method converts each categorical values into integer value. For this problem, we are going to work with ordinal encoder. So it's pretty much simple to use an ordinal encoder. First, what we need to do, we need to initialize the ordinal encoder. Then what we are going to do, we are going to use a method known as fit transform, which will train the data as well as transform the data. So here, as you can see that in the parameters, I have provided the action column. Now let's move forward and run this code. Now, as you can see that we have transformed our column, and you can have a look at it. Now let's see how many unique values are there in the action column. For that, we are using a function known as unique. In the unique column, we have 4 values, so that are 0, 1, 2, and 3. So this is going to be our target column. Now we have prepared the data set. The next step in the process is to have the training set as well as the target column separate. And in order to achieve that, we are going to use the pop method. In the next step, what we are going to do, we are going to split the data into training and testing. For that, we are using train test split. And in the parameters, I have provided the training set, the target column, random state, and the test size for the testing data set. Now let's move forward and run this code. Now everything is done. Now we are going to talk about min-max normalization. Each attribute is scaled to a range between 0 and 1. So this can be achieved using Scikit-Learn's MinMaxScaler. The transformation is given by the formula. The value minus the minimum value of the column divided by the range. So that is the maximum value, subtracting the minimum value. Now let's take an example to understand this properly. Let's assume we have a data frame and we have 3 values, 10, 20, and 30. Now if you apply a MinMaxScaler to the attributes, so the value would be converted as below. The minimum value is 10 and the maximum value is 30. So 10 would be converted as 0, 20 would be converted as 0.5, and 30 would be converted as 1. So as you can see that the minimum value that we are getting is 0 and the maximum value that we are getting is 1. So this is how MinMaxScaler works. Now let's have a look at the algorithm. First, we need to initialize the MinMaxScaler. Once we have done that, we can use the fit method. once we have initialized the min-max scaler, we need to find the minimum and the maximum value for each attribute. This is achieved using the fit method. Next, what we are going to do, we are going to transform the data with a fitted min-max scaler. So what it does, once fit method calculates the minimum and maximum of every column, then the transform method applies it to every column of the data that has been provided. Now let's have an example for that. Here, as you can see that we have initialized the min-max scaler. Then we are going to train the min-max scaler using the fit method, and we are creating a copy of the training set. Then what we are going to do, we are going to transform the data with the fitted min-max scaler over here. Now run this code and let's have a look at the transform data. So this is how the transform data looks like. As you can see that our data has been scaled in a range of 0 and 1. We can also check the maximum and the minimum values to check whether the data has been properly scaled or not. So let's have a look at the maximum values before we have scaled the data. So as you can see that before normalization, each attribute has a different range of values. Now let's have a look at the maximum values after we have scaled the data. So as you can see that the maximum value for each attribute is 1. So now what we are going to do, like all these steps can be reduced to 2 operations. For that, we are going to use a pipeline. A pipeline will allow us to implement multiple stages using a single pipeline. And to implement the pipeline, we just need to do 3 steps. The first, we need to initialize the pipeline. Then we need to use the fit method to execute the steps. And third, what we are going to do, we are going to use score method to calculate the model's performance. So now let's move forward and do this. Here we are using a pipeline pipe min-max, and we are using a method known as make pipeline. Inside that, the first step is to initialize a min-max scaler. Then we are going to implement a logic regression model, and we are saying that maximum iteration needs to be done for this model is 2000. Then what we are going to do, we are going to fit the pipeline using the training set, and then we are going to score the model performance using the testing set. Let's run this code and see what the score would be. So as you can see that we are achieving a score of around 96%. This might be different if you're using a different data set. In case if you're using a different data set, write down in the comment section what score you are getting on your data set. So this was all about min-max normalization. Now we are moving forward with z-score normalization, or it is also called as data standardization. Scikit-Learn provides us with StandardScaler, which standardizes the features for us. The z-score of a sample is given by the formula data point subtracting the mean value, and the whole is divided by the standard deviation. Now let's have a look at the algorithm, how it is achieved. First, we need to initialize a standard scaler. Then we are going to use a fit method. So what it does, once we have initialized a standard scaler, we need to find the minimum value, we need to find the mean and the standard deviation of each attribute. This is achieved using the fit method. Then we are going to use the transform method. So what it does, once fit method has calculated the mean and standard deviation of every column, the transform method applies it to every column of the data that has been provided. So in this example, we are going to initialize a standard scaler, fit it on our training set, and transform the testing set to check the score. So now let's move forward and see a running example. Here you can see that we are initializing a standard scaler, then we are training the standard scaler with a training set. Then we are making a copy of the training set and we are calling it as xtrain scaler. Then we are transforming the new data frame by using a transform method with the standard scaler that we have just fitted. Now let's run this code and see how the transform data looks like. As you can see that we have negative values also. So in standard scaler, it ranges from -1 to 1. So running the code above gives us the scale data set. Each attribute has been standardized to 0 mean and unit standard deviation. So what we can do, we can actually check the values by checking the mean before standardization and the mean after standardization. So let's run this code and see what was the mean before standardization. So here you can see that we have multiple ranges, multiple different mean for each and every attribute. So now let's have a look for the mean after standardization. So as you can see that the mean has been standardized to 0. Just like the mean, we can also check the standard deviation before and after applying the standardization. So let's check the variance before standardization. So as you can see that it is pretty much different for each and every attribute. Now let's have a look at the standard deviation after standardization. So as you can see that each attribute has been scaled to a unit standardization. So as what we have done above, we are going to implement the pipeline. So that would be pretty much easy to go through. So what we are going to do, we are going to create a pipeline, and we are using a method make pipeline in which we have a standard scaler. Then we are going to implement a logistic regression model, and then we are going to train the pipeline using the training set. Let's move forward and run this code. So as you can see that our pipeline has been created. Now what we are going to do, we are going to check the score of the model performance. For that, we are going to use the score method, and we have provided the testing set. So we are achieving a score of around 98%. So it's actually better than min-max normalization. The concept of using different normalization method depends upon the type of data set that we are working on. In case if you are working with a different data set, try to write down in the comment section what score you are getting for this StandardScaler. So this was all about data standardization or z-score normalization. Now we are going to talk about robust scaling. Scaling. A robust scaler removes the median of the attributes and scales the data between the first quartile and the third quartile. Scikit-Learn provides us with a robust scaler to scale the features. Now let's have a look at the disadvantage. This method cannot be used when the data is so sparse. Now let's have a look at the algorithm. So it's pretty much similar to the algorithm that we have talked about. First, we are going to initialize the scaler. Then we are going to train the scaler using the fit method. So once we have initialized the robust scaler, we need to find the median and the quantiles for every attribute. This is achieved using the fit method. Then we are going to transform the data with a fitted robust scaler that we have done. So once the fit method calculates the median and the quantiles for every column, then the transform method applies it to every column of the data that has been provided and returns the scale data. Now let's go through an example so that we will be able to understand this concept in detail. So first we are going to initialize the scaler, then we are going to train the scaler using the fit method. So then what we are going to do, we are creating a new copy of the training set using the copy method. Then we are going to transform the data using transform method. Now let's run this code and let's have a look at the transformed data set. So this is how our new transformed data looks like. So in order to check if the median has been removed or not, let's go ahead and check it out. First, we are going to see the median of the data before applying the transformation. So as you can see that each attribute is having a different median. Now let's have a look at the median once we have scaled the data. So as you can see that the median has been removed. So this is how a robust scaler works. So in order to make the process simpler, we are going to implement a pipeline similar what we have implemented before. So we are going to use the make pipeline method, in which the first step is to implement a robust scaler. Then we are going to implement a logistic regression model. Then we are going to train the data using fit method, and we are providing the training set. And then we are going to score the model performance, and we are going to provide the testing set. So let's run this code. It might take a couple of seconds depending upon your computation power. So running the code above, we can see that the model has been achieving the highest score so far. So this actually depends on the type of data set that we are working with. In case if you are working with a different sort of data set, please write down in the comment section what score you are getting on your data set. So this was all about this video. We learned about min-max normalization. We have talked about z-score normalization, and we see how a robust scaler can be used. In case if you have liked the video, please hit the bell icon and subscribe to the channel. If you want to go through more tutorials and blogs, please go to moredatascientist.com and you'll be able to take your first step towards machine learning. Thank you. I'll meet you in the next video.